This is a video lesson for Module 1, Lesson 13. The Lesson 13 learning target is I can use place value understanding to decompose to smaller units once using the standard algorithm for subtraction and tape diagrams. So we are going to be doing a little bit of an introduction to the standard algorithm for subtraction, and we're also going to look at how the standard algorithm for subtraction works by comparing it to subtraction using a place value chart. So the first problem of this lesson is going to go into a lot more detail, and then the second and third problems are going to be just more practice and examples of how we can use the standard algorithm to solve subtraction problems. So let's go ahead and jump into the first problem here. We are going to be solving the subtraction problem of 4,259 minus 2,171. The first thing I'm going to do is I'm going to draw a tape diagram that represents this problem just to help me understand what's exactly happening when I'm subtracting these numbers. So in a subtraction problem, when I'm drawing my tape diagram, the whole of the subtraction problem represents the first number, which we call the minuend. So that's what the name of the first number in a subtraction problem is. And that is equal to the whole of the tape diagram, so 4,259. And then the second part of the subtraction problem, which is called the subtrahend, is representing one of the pieces of our tape diagram. So one of these pieces is going to be worth 2,171. So that means that we are trying to find out what this other piece is. So this really helps us see that subtraction is the inverse of addition, because we know that 2,171 plus something equals 4,259. So it really shows us with the tape diagram how subtraction and addition are related to each other. But now that we have a firm understanding of what we're asked to do, we're looking for this value right here, we're going to use the place value chart and the standard algorithm to help us solve this problem. So I have the place value chart set up already. I'm also going to set up my numbers here for solving this with the standard algorithm. Oops. And when I'm writing my numbers for the standard algorithm, just like addition, I want to make sure that my ones place is lined up with my ones place, and my hundreds with my hundreds, my tens with my tens, my thousands with my thousands. I want to make sure I'm subtracting the correct place value from the same place value of the other number. So I'm going to start by representing the minuend in red with discs on my place value chart. So 4,000s, 200s, 5 tens, and 9 ones. And then to show my subtraction, I'm going to be crossing out the different values of my subtrahend on the place value chart. So I'm going to start with my ones place, and when we're doing subtraction, we always want to make sure we're starting with our ones place, or our smallest place value. And I'm going to start, and it looks like we have one in our subtrahend, so I'm going to cross out 1 1, and that leaves us with 8 ones for our answer. And when we're solving with the standard algorithm, that process of crossing out this 1 looks like subtracting 9 minus 1 and getting 8. Now going back to our place value chart, looks like we have a 7 in the tens place here, so I need to cross out 7. But when I look at my tens place, I only see that there are 5, 1, 2, 3, 4, 5 tens. So this means I need to do some decomposing, or if you're familiar with our puzzle packing unit, some unpacking of the next biggest place value. So what I'm going to do is I am going to exchange or decompose or unpack one of these hundreds, and inside one of the hundreds is actually going to be 10 tens. So I'm going to write these 10 tens right here. So this 10 became, or this 100 was unpacked or decomposed, and it became these 10 tens. So now that I've done that, I have now 15 tens in my place value chart. So I'm very easily able to cross out 7 of them now. And once I've done that, I can count to see how many I have left. And I have 8 left. just like my ones place. Now this process on the standard algorithm looks a little bit different, but the fundamental concept is the same. So since we have 5 tens and we need to get rid of 7, we don't have enough. So I'm going to decompose one of my hundreds, which leaves me with 100 left over. And then since inside that 100 is 10 tens, I'm adding 10 tens to my previous 5 tens, so I have 15 tens. And now I have 15 minus 7 tens, which is 8 tens. So a little bit different, but we're showing that decomposition by reducing one of the hundreds and adding 10 tens to my previous value. Now that I've done my tens place, I'm moving on to my hundreds place, and I have 100 that I need to remove from the number. Luckily, I have 100 left, so I'm going to go ahead and cross that out, just like this. And on the standard algorithm, that looks like subtracting this one right here, taking this one, and subtracting this 100 down below, and that leaves me with 0 hundreds. And finally, I look to my thousands place, and I have a 2 in the thousands place. So I'm going to go ahead and cross out 2 of my thousands on my place value chart. And over to our standard algorithm, that same exact step looks like taking this 4 and subtracting 2 away from it. So I had 4 thousandths minus 2, which is 2 thousandths. And it looks like I forgot to write my digits here. That's okay. I'm just going to go ahead and write my answer down. So you see in both cases with the place value chart and the standard algorithm, I get the same answer of 2088. So hopefully seeing these two strategies being used at the same time, the place value chart and the standard algorithm, can help you see the connection between the two different strategies. So now we're going to move on to another problem. For this problem, we're only going to work on using the standard algorithm. So we're going to start the problem the same way as before, drawing a tape diagram that represents the subtraction problem. So I'm going to draw my diagram right here. And I know that my first part of my problem, which if you recall from the previous problem, is called the minuend. The minuend is going to represent the total value of the tape diagram. And the subtrahend, which is the second problem, is going to represent one of the pieces of the tape diagram. So that means the question or the answer to this problem is going to be the other piece of this tape diagram. So I'm taking my minuend, subtracting my subtrahend, and then that's going to give me my answer. So I'm going to represent this problem in the standard algorithm format here. And I'm lining up all my place values so that they match with both numbers. So my ones match with my ones place for both numbers, and so on and so forth. And now I'm going to go ahead and subtract. So I'm looking at the top number. I have 2 ones, and I'm subtracting 0 ones away, or I'm getting rid of 0 ones, so I'm left with 2 ones. Moving over to my tens place, I have 2 tens right here, and I'm subtracting 1 10. So that leaves me with 1 10 left over. Now I move over to my hundreds place, and I see that I have 4 hundreds. But then I look, and I need to be taking away 5 hundreds. So when the value of that subtrahend is larger, that second number, or the number down below, is larger than the one up top, then that means I need to do some of that decomposing or that unpacking from the next highest place value. So I'm going to move over to the thousands place. I'm going to unpack one of my thousands, which will leave me with 2. And that adds 10 hundreds to my hundreds place here. So I'm going to have 14 hundreds, the 10 plus the 4 I already had. And what this allows me to do now is I can take 14 minus 5, which is 9. And then now I have 2 thousands. I'm taking away 1,000. That's 1,000. And I have 2 ten thousands, taking away 1 10,000. That's 1 10,000. So that leaves me with an answer of 11,912. So let's take a look at one more problem here. This time we're going to look at a story problem and see how we can use the same process or strategies for subtraction using a tape diagram and the standard algorithm to help us solve this problem. So this problem reads, a paper mill produced 73,658 boxes of paper. 8,052 have been sold. How many boxes remain? So I'm going to draw a tape diagram to represent this problem here. This helps me picture what the problem's asking me to do. I can see that one of the important numbers is 73,658, and this is representing the total number of boxes of paper that the mill produced. So this is going to be my total here. So this is boxes of paper. And then another important number is this number 8,052, and that's the number of boxes that have been sold. That's a pretty small number, so it's actually going to be a small portion of our whole here. So 8,052 boxes sold. So that means this big chunk over here is the boxes that remain. So that helps me write a number sentence here that I'm actually going to be solving 73,658 minus 8,052. And I'm going to use the standard algorithm to solve this problem. So to do this subtraction, I'm going to use the standard algorithm and start with the smallest place value, which is the ones place. So I have 8 ones minus 2 ones is equal to 6 ones. 5 tens minus 5 tens is going to be 0 tens. 6 hundreds minus 0 hundreds is going to just leave me with 6 hundreds. And then I have 3 thousands, and I need to take away 8 thousands, and I don't have enough. So I need to do that decomposing or unpacking from the next highest place value. So I'm going to unpack one of these 10 thousands, which would leave me with 6. And inside that 10,000 is 10 thousands. And so that gives me a total of 13 thousands now. And so now I'm able to take 13 minus 8, and that is 5. And then 6, and there's nothing in the subtrahend in the 10,000s place, so that leaves me with 6. So my answer that I got is 65,606. Now, if I want to check my answer, one of the cool things about subtraction is that, and this is something we talked about earlier, is that it's really closely related to addition. So if I were to plug this number, my answer, back into my tape diagram, I could do an addition problem of 65,606 plus the other part of my tape diagram, 8,052. And the answer that I would expect to get would be my total, 73,658. So I'm going to check with addition here. 6 plus 2 equals 8. 0 plus 5 is 5. 6 plus 0 is 6. 5 plus 8 is 13. And 6 plus 1 is 7. So I get my total answer of 73,658. And that matches exactly with the total of my tape diagram. So I have checked my work, and I have guaranteed that my answer to the problem is there are 65,606 boxes remaining. So hopefully now you're feeling pretty comfortable with this idea of subtraction using the standard algorithm. We took a look at tape diagrams and how they can help us understand a subtraction problem, and we even looked at how we can use addition to check our answers to a subtraction problem. So you should be ready to answer all the questions in the lesson 13 problem set, but as always, if you get stuck or need a refresher, feel free to come back and rewatch any parts of the video that you need help with. So good luck with the problem set, and thanks for watching.